mentioned earlier, we will consider some problem with variable density. We try to find the total mass of this object. So, we need to find the total mass of this object bounded by these 4 planes. The planes are the same. Here the density is a variable. It depends on the coordinate Z. Now, again we consider the infinitesimal element. So, the volume is this infinitesimal volume. The mass can be obtained by multiplying it by its density. So, density times the infinitesimal volume gives you the infinitesimal mass. After that, mass of the infinitesimal element is this one. Now, we need to figure out the limits like we did earlier. X varies from this plane to this one. So, in this plane x is equal to 0, in the plane sitting to the right hand side the equation is this. So, x goes from 0 to this one like in the previous example. Then we what we do is we project this onto this plane ignoring x axis. On yz plane it should be a triangle like this. Again y goes from this line, here y is equal to 0 to this line. This line can be obtained by taking x is equal to 0 in this plane. So, you have 6 minus 2z minus z, 2y minus z. So, from this when you plug in x is equal to 0 you will end up with this one. Now, make y the subject. So, you get 6 minus z over 2. So, the equation of the line, this line is this one. You can also always see that when y is equal to 3, z is equal to 0, and at the same time when z is equal to 6, y is equal to 0. So, that is the line. So, here this line is y is equal to 0, this one is y is equal to this. So, the limits of y should be these two. I think this is not important to us, sorry. And then we consider the last axis. So, you project everything onto this one. Here the limits are from 0 to 6, this one. Now, total mass can be obtained by assigning these guys as limits. So, limits of x are from 0 to this one, limits of y from 0 to 6 minus z over 2, limits of z are from 0 to 6. Now, the density is z. Now, you can just put a pair of braces just to separate that entity. Then when you integrate z, the variable of integration is x. Therefore, z is treated as a constant. So, this is what you get. Assign the limits, you will end up with this one, this limit for x, then 0 for x. There is nothing comes from the second limit. So, you will end up with this one. Now, this is a double integral. You are more familiar with the double integrals. Now, you better, I mean, since you have a product, you better expand this. So, once you expand it, you will end up with this, and at the same time we pull out 3 outs, I mean we pull out 3 for the sake of simplicity. So, you will end up with this. Now, you can integrate term by term. When you integrate this with respect to y, remember z is a constant, therefore, you have 6 z times y. Here integral of 2y is y squared times z. Here again a constant, so z squared times y. Now plug in the limits, you will end up with this. Now, you can simplify this. Okay. So, once you simplify it, you will get this one. Then again by collecting similar terms, like you can see there are 2 cubes, you can combine it into this one. The squares, these 2 will go away, add up to minus 3 z squared, and the terms carrying z, linear terms, will give you 9 z. Now, integrate it term by term, it is a straightforward exercise. The limits are from 0 to 6, Then plug in the limits, replace Z by 6, so you will end up with this. Simplify, once you simplify this expression, you will get 9. So the weight is 9 kilograms. Since the density is given as Z kilograms per cubic meter. Okay, so this is how you apply a triple integral to find the total mass of a variable density. Similarly, in vector fields, sometimes you will get an object with variable charge density. So if you want to find the total charge, you can employ a same technique to find the total charge of that object. Okay. So with this, the introduction is over. However, we have to deal with transformations if the area is not bounded by planes. Sometimes the area, the volume may be a volume may have some cylindrical shape or a spherical shape. So once you encounter some shapes like that, assigning limits would be extremely difficult. You might get square roots, and it will be extremely difficult to deal with those type of integrals without some coordinate transformation. And at the same time, when it comes to vector fields, you will have to deal with those type of shapes very frequently, right? Therefore, having coordinate transformations in your toolbox is a must. So we will consider those type of transformations, basically cylindrical polar coordinates and spherical polar coordinates in the subsequent videos. So with that, we can finish the triple integrals. After that, we can move into vector fields. All right. Thank you very much.